for joining us today. Welcome to the Center for Professional Advancement's free preview webinar with Dr. Vahid Ebadat. This webinar serves as a preview for combustible dust hazards, electrostatic hazards in the processing industry, fire and explosive hazards, and related topics. We are very happy to have Dr. Ebadat with us conducting this training today. Dr. Ebadat has worked extensively as a process and operational safety consultant for the processing industries, including chemical, pharmaceutical, food, wood, pulp and paper, and metal. Dr. Ebadat is a regular speaker at training courses on gas and vapor flammability, dust explosions, and controlling electrostatic hazards. Dr. Ebadat, the session is in your hands now. Thank you so much for being here today.
Right. Thank you for the introduction and good morning, everyone. As you heard, my name is Vahid Ebadat. I am from Solent Process Safety, which is a consulting, training, and testing company. We specialize in combustible dust hazards, static electricity, gas and vapor flammability, and thermal instability. As you heard, this preview webinar is intended to be a sort of introduction to our upcoming and obviously longer on these topics. So in the next few minutes, I will be talking to you about the conditions that are required for fires and explosions to occur. I will also cover the requirements of the new NFPA 652 standard on the fundamentals of combustible dust. Then I'll move on to talk briefly about electrostatic hazards and their control. And finally, I'll talk about how we can ensure safety by taking preventive or protective type measures for our processes and facilities. So starting with the fire triangle, I'm sure most, if not all of you are familiar with this concept. It basically says that in order to have fires or flash fires, we need to have three components together at the same time. And these components include a liquid, vapor, or mist, a flammable gas, or indeed a combustible solid material. We also need an oxidant to support the combustion process, and again, oxygen in air is ample oxygen for combustion under normal conditions. And of course, once those two components are together, we have a flammable atmosphere, and in that case, if there is strong enough ignition source, we'll end up with a fire or flash fire. Now, when it comes to combustible dust situations, again, for flash fires or deflagrations to occur, we need to have an explosible dust with a small particle size to support flame propagation. That dust needs to sort of become airborne and create an explosible dust cloud with a concentration above the minimum explosible concentration, or MEC. Again, we need to have an oxidant to support the combustion. Of course, those of you who have powder or dust handling or processing facilities and operations, I'm sure you agree with me that these three conditions usually are expected at least at some point during many of your handling, transfer, processing, dust collection, and packaging type operations involving powders. And of course, in that case, if there is, again, a sufficiently strong ignition source, one would end up with a flash fire or deflagration. Now, if these conditions occur in a confined space, and that confined space could be one of your processing equipment or indeed one of your rooms or buildings. In that case, the pressure increase, pressure buildup as a result of this deflagration could basically exceed the strength of the vessel or enclosure, and in that case, we'll end up with an explosion. I should mention that vapor or indeed dust cloud explosions can create maximum explosion pressures of anywhere between 6 and 12 bars. And in contrast, even a seemingly strong process equipment like a dust collector can only withstand a maximum of about 0.5 bar or atmosphere. So you can imagine if you have these conditions in your process equipment and you don't have proper preventive and protection measures in place, the results could be devastating. So this is what we call, or what is referred to as an explosion pentagon, having combustible dust suspended in the form of a cloud with sufficient oxygen, an ignition source, all confined. So sometimes you refer, you see this explosion pentagon, and that is really what it means. Now, as far as ignition sources are concerned, here is a list of probably an almost exhaustive list of potential ignition sources. Of course, one doesn't expect to see all these ignition sources in a facility. Many of these ignition sources can be adequately controlled by administrative measures like hot work operations and so on. But some of these ignition sources, such as spontaneous or self-heating or static electricity, could be inherent within the chemical, that being a powder or indeed a liquid that you handle or process as part of your product. And some powders and liquids, for example, are electrostatically very insulating. They can become electrostatically charged up, create discharges that are capable of igniting their own vapor or dust clouds. And as you can imagine, then control of those ignition sources would require more insight, and they are a little more challenging to identify and control. And again, I will be talking about how we can do that practically during our upcoming 90-minute webinar. So let's now talk briefly about NFPA 652 standard on the fundamentals of combustible dust. As I mentioned earlier, this is a relatively new standard, and it's intended to provide some general measures for management and control of dust, fire, and explosion hazards. It's also intended to direct you to appropriate NFPA industry or commodity-specific standards that are applicable to your types of operations. And I guess most importantly, it's intended to create proper relationship and hierarchy between this standard 652 and applicable industry or commodity specific standards. Basically, there are 4 requirements in NFPA 652 from you as the owner or operator of a facility. First step is that you need to determine whether or not the dusts or powders that you have are combustible. Go or no go. And indeed, if the powder or dust that you're handling or processing in your facility is combustible, the next step is that you need to conduct a dust hazard analysis, or a DHA. Any hazard that is identified through this DHA now needs to be managed. NFPA 652 provides 2, if you like, options for you. One is a prescriptive approach. Basically, you can follow the requirements that are prescribed in the NFPA 652. Or if you find that some of those measures, those prescriptive measures, are not practical for your operation and processes, then you are permitted to do a risk assessment and to come up with alternative measures that would provide you with the same level of safety. So there is some freedom here for you. And finally, NFPA 652 requires you to have a written safety management program in place to manage basically safety of your people and your facilities and community against potential dust cloud explosion hazards. So this DHA is a systematic review to identify and evaluate potential dust fires and explosions in your facilities. And it must be conducted, it is a requirement of NFPA 652, that it must be conducted by someone who has expertise in identifying, assessing, and controlling dust explosion hazards. NFPA 652 came into effect in September of 2015. It basically says that you have 3 years to conduct a DHA and then manage the identified hazard. Some commodity-specific standards, like the one for food processing, in fact, give you 5 years for those industries to be in compliance with the requirements of NFPA 652 DHA. However, if you are building a new facility or you are doing some modifications that financially are in excess of 25% of the original cost, then you need to do a DHA as a part of the project. Right, so in the remaining time, let's talk about some of the measures that one can take to ensure safety. And again, I emphasize that you'll get more detailed information by attending our 90-minute webinars. So in order to ensure safety, we can go back to the fire triangle and see if we can effectively remove any one side of that triangle. If you can reliably remove the fuel or the oxidant or indeed the ignition source, you avoid having fires, and that will be it. However, if you take these measures, these preventive measures, but at the end, you still do not feel comfortable that you've reduced the risk to a tolerable level, then in addition to taking these measures, not instead of, but in addition to taking these measures, you also need to consider explosion protection. So going through the list, starting with the avoidance or control of the fuel, here are some headlines basically. You need to consider appropriate equipment design to contain the fuel, be it flammable liquid or combustible powder or gas within the process equipment and preventing it from escaping into the process building. If practical, possible, and you should also maintain the liquid temperature below its flash point temperature, and basically by doing so, you avoid having a fuel or a flammable atmosphere in the headspace of the tank. For powders, again, if practical, maintain the dust cloud concentration below its MEC. The next step is making sure that you have an effective housekeeping program, ensuring that dust accumulations are removed or at the very least are below the level that would give rise to an explosible dust cloud. Housekeeping really is quite important here, and many of the major dust explosions that have occurred and have been reported extensively here in the US. Most of the fatalities, if not all, and the devastation has been as a result of secondary explosions because of poor housekeeping rather than the initial explosion in a process equipment. Finally, you need to consider exhaust ventilation. So very often you need to have local exhaust ventilation and effective local exhaust ventilation in locations where you do transfer of dust or powders or liquids from one vessel to the other, and there is a possibility that that fuel, that dust cloud or liquid vapor could escape into the facility. Control of oxygen basically is possible if you have confinement, so that you can replace some of the oxidant with an inert gas and reduce the oxygen concentration to below the level that is required for combustion. And that limiting oxygen concentration for combustion is referred to as LOC. It is a laboratory test, and that LOC level is dependent on the nature of the powder or liquid that you have, the nature of the fuel, and the type of inert gas that you use. Common inert gases that are used in industry are nitrogen, CO2, and sometimes argon. NFPA 69 provides a lot more information on inert gas blanketing techniques. So if you're interested in reading more, and again, we'll cover this in more detail in our 90-minute webinars. I showed you this slide before. For the interest of time here, I only cover electrostatic discharges briefly. We'll talk more about the other ignition sources at our webinars. So if you can imagine, when it comes to electrostatic hazards, the first step is for static charge to be generated. Commonly in process industries, static electricity is generated whenever any two materials come together and separate. So if you can imagine, every time you put your foot on the floor and lift it up, you have a static charge on the sole of your shoes and also on the floor. If you have powder going through a pipe, it makes multiple collisions with the pipe wall, so powder particles become charged up. So does the conveying pipe. Then you have liquid flow through pipes or mixing of liquids in a tank. A static charge generation is expected both on the liquid and on the tank. So again, anytime any two surfaces come together and separate, you expect a static charge generation to occur. Static charge generation, though, on its own is really not a big deal. You'll end up with electrostatic hazard if the generated charge, in fact, can build up somewhere. So it is really the accumulation of static charge that could be an issue. Static charge could build up on isolated metal items of plant, on isolated people, on non-conductive powders and liquids, and on non-conductive items of plant. And of course, if the discharge from electrostatic charge generation and buildup is more than the minimum ignition energy of the discharge of the flammable atmosphere, rather, then you will end up with flash fire or an explosion. So what do we do to control electrostatic hazards? First step, make sure that all the conductive or metal items of plant are bonded together and grounded. For the purposes of electrostatic hazard control, a resistance to ground of less than 1 million ohm would be more than adequate. As I mentioned earlier, insulating or non-conductive materials like plastic pipes and hoses, liners and bags, drums, and so on, are non-conductive, and grounding of such items really will not help you dissipate the static charge to ground. Now, if your assessment identifies electrostatic discharges from these items as a potential ignition source, then you really need to consider some alternatives. And one alternative would be using conductive or static dissipative materials instead. Human body is also a conductor, and if left ungrounded, like by wearing standard safety shoes or by working on an insulating flooring like an epoxy coated flooring, human body during normal activity could become electrostatically charged up with voltages of about 10 to 20,000 volts. That translates into discharge energy from a human body of about 10 to about 30 millijoules. In contrast, a propane atmosphere would require maybe something like 0.2 millijoules of energy to ignite. So when it comes to flammable gas and vapor atmospheres, electrostatic discharges from a human body would be more than enough to ignite those atmospheres. And of course, there are many powders with minimum ignition energies less than 30 millijoules. Confectionery sugar, for example, probably would require something like 4 to 5 millijoules of energy. So again, a discharge from your fingertip could ignite a very fine sugar dust. So you really need to make sure that in atmospheres where discharge from a human body could be an ignition source, that your operators are grounded. Probably the most practical way of grounding operators is through the use of static dissipative shoes and conductive or static dissipative flooring. In fact, you can buy these days static dissipative safety shoes readily, and there are conductive or static dissipative floor coatings that are also available. Right. So I very briefly talked about some of the explosion prevention measures that one could sort of consider. As I said earlier, if those measures are not enough to give you the level of safety that you require, then in addition to taking those measures, you need to consider explosion protection. Explosion protection basically means that you will have an explosion in your facility at some time, albeit very infrequently. But you've designed the facility in such a way that in case of an explosion, operators, people won't be harmed, and the facility will not be damaged, and you can, with very little effort, can get back to production. Explosion protection measures include explosion relief venting to a safe location, which basically very often means outside of the facility. Can also consider explosion suppression by injecting suitable suppressant, or you could consider for certain applications explosion containment. In other words, building the equipment to be able to withstand the maximum explosion pressure. I will be discussing these options in more detail during our webinar on dust explosions. So in summary, effective management of flash fires and explosions often requires you to have applicable data on the flammability, ignition sensitivity, electrostatic, self-heating, and explosion properties of the fuels that are present, a good understanding of all your operations and processes, being able to recognize the locations where explosible atmospheres could be present, both during normal but also abnormal operating conditions, being able to recognize potential ignition sources that could be present, again, under both normal and also foreseeable abnormal conditions. Then you need to ensure safety through really properly defined fire and explosion prevention and protection measures. We refer to that as basis of safety, And once those measures are in place, you really need to have a proper program to enable you to regularly review and maintain your process and safety data and information, your control systems, your processing equipment, and the facility. With that, I thank you for your attention, and I look forward to meeting you again during our 90-minute webinars on combustible dust hazards, electrostatic hazards, and fire and explosion hazards. Thank you.
Thank you, Dr. Ebadat. We are excited about the upcoming courses on this topic. And to our webinar attendees, you can get more information on our website, CfPA.com. You can find the full description there for each course and download the brochure, as well as get information on group discounts. So this concludes our training/course preview today. Thank you again, Dr. Vahid Ebadat, for sharing your expertise today. We look forward to the full training sessions.
My pleasure. So do I. Bye-bye.
All right, everyone. Have a good day, everyone. Bye.